Check it out, guys. This iPad Air 2 was destroyed. This motherboard has a bunch of ripped pads where the charging port was because another technician attempted this repair and totally messed up. So in today's video, we're going to try to save them by fixing all these ripped pads. There's about 13 of them, and we're going to go through the process of adding jumpers, installing the new port, and hopefully get it all working. So hi, I'm Jesse from VCC Board Repairs. Thanks a lot for joining us here on the channel. If you like watching me try to save other technicians on these type of jobs, smash the like button, subscribe to the channel if you want to see more videos like this, and share this video with all your friends. Don't forget, I will always link down below the description all the tools I use in today's video, as well as some other cool links like where to buy this t-shirt. So let's go ahead and get started with this video. So let's get right to it. Let's do a visual inspection of this charging port. Now the port is obviously already missing, and you can see there is some empty spots. So the charging port, look, another one just came loose. So the charging port is a flex. I have it already here ready. It is a flex that kind of solders through the cable itself onto those pads. And what happens is when people are taking off the original, they'll either pull it too soon, or I don't know what happens. They just mess up. Especially if you don't have too much experience with soldering, super easy for you to make this mistake. I do have another video on a charging port repair where I go in detail how to properly do this with very low risk of damaging any pads. So let's take a look here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and maybe some other ones. These kind of feel a little loose. But yeah, about 13-ish, maybe 14 if we count this one. But one thing is, if you understand how these are designed, how these circuits work, you'll realize you don't have to replace every single one. So let's go through it. So this is, just by looking at it, you can tell that there's no trace going out of it. So here, this one, you can see how it just nothing, whereas this one has a little trace next to it. So this one's most likely ground. And what we can do is actually take a look at ZXW. But before I do that, let's just do a visual inspection here first. So I can see that this one's going to need to be jumped because you can see there's a trace here that kind of connects to the line. This one's another ground one. This one looks critical. There's a trace with it. This one appears to be ground. Now here's two that are missing, and you can see the little traces here. So we'll need to jump those. You can see here some, I guess they try to fix it, but probably had no idea what they're doing. So this one's missing, but you can see a little trace here, and they exposed some ground plane outside of it here. This one looks ground, this one looks like ground. These, you can see the traces here, so these will be jumped. These two will be jumped. This one, I'm not gonna jump it just because there's enough pad here left to solder onto the port. And then this one is actually two pads all connected to the same line. So most likely you don't have to jump that. So what I can do is actually check on the flex itself. So we're looking at 1, 2, 3, 4, 5. So number 6 and 7, do they have continuity in the flex? 1, 2, 3, 4, 5, 6, and 7. And if we use our multimeter, my meter in diode mode will beep like if it's continuity. So 1, 2, 3, 4, 5, 6, and 7. Yeah, there's continuity. So if I solder one, because these are connected within the flex, it'll just automatically connect the other one, and there'll be no issue with this, with that. So we can skip that one. So really, we only need to do 1, 2. This one's still attached. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 jumpers. So Let's take a look here on ZXW. So let's check this first one. Like I said, 1, 2, 3, 4, 5. So the fifth one, 1, 2, 3, 4, 5. That's this one here. If it's gray on ZXW, it's going to be ground. And ground are not necessary. Although here you can kind of see a little trace. But that's not, that's ground. So not necessary. The next one is this one, which we do see a trace. That's this one. And then skip 1. And then there's a 2. So we gotta do, well, we gotta do one. Actually, it says it is the same line. So these two right here that you see on the scope are the same line. So if I use my multimeter and so they're connected within here. And let's see, this is pins number 1, 2, 3, 4, 5, 6, 7, 8, and 9. So same thing here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. These two. These have continuity within the flex. So we don't need to jump that one. So we've kind of eliminated one. So jump this one. And we can skip that. I'm pretty sure these will need to be jumped, which you kind of visually just tell by the little traces above it. And they're definitely separate lines, but also you'll see how right above it. So if you for example, this whole pad was missing and you have nothing to jump to here, you could always jump to here after you install the flex. So that's a strategy in those type of scenarios where sometimes it just, the pad is ripped so far, so gone that you can't jump here. You have to jump the next spot in the line, which would be here. So this is an option. In my case, I do see the traces there. I do see a piece of the you can see there's still some here, there's still some here. So yeah, definitely need to jump those. Next is this one, same thing. Definitely need to jump it. And what it does exactly, it doesn't really matter at this point. So we're not going to focus too much on the actual name of the lines. And look at that. This one is, so like if we look at the last 1, 2, 3, 4, these four here, they're all part of the same line. So let's do the same test. Continuity mode. So if I touch any of these, this is all like interconnected elsewhere on the circuit, so that's fine. And then if we check the ports, check those same pads on the port. So, oh, look at that. Oh, the very far, the first one here on the right is not the right line, so you can see these are all connected together. So yeah, we could skip those as well. So this is why it's important to understand what you're doing here, because you can use this to your advantage to save yourself some time. So don't need to jump any of these. And then, yeah, don't need to jump this one because we already checked that one. So really, we just need to do this one here. So you can see the outline. So you really want us to scratch within that line to expose like a big section of copper. So we just go like this. And you want to stay within the lines, because if you go outside, then you're gonna basically expose ground, and then it's could cause problems. Like I said, these are not gonna be messed with. And there's these two right here. So you can see the little nub here that we're going to scratch out, that we are scratching out. Just got to be real careful, just scratch gently. And you only want to expose the top layer. You don't want to dig into the layers of the board because then you'll have problems. Essentially, you want to expose enough so that you can run a jumper to it and have a solid solder joint. And then I think that should be fine for this one. This one has a little piece of, still has a little piece of that little trace, which might be a problem. So I'm just going to cut it off. Let's get that out of the way. So just scratch out, expose the trace so that you can jump to it. Alright, so this one's the one someone else tried. Obviously, they never use coloring books where you have to color within the lines, because you can see they went outside the little trace here. So just be within the lines, and then we'll just UV mask that off so it doesn't risk any bridging. Alright, so that's pretty much it. Just these 5 or 4. 1, 2, 3, 4. So let's actually do some soldering here. Some flux on the sections you're going to solder. So we're essentially going to pre-tin the pads. This makes it so when we add the jumper, it will be easier to solder onto. And this one goes like that. Alright, so we added some solder. Of course, I got some here on this ground plane, but that's fine. It's not making contact. Then we're going to use solder lugs. So if you saw my Nintendo Switch video, these are little pre-made jumpers, essentially. So I'll link these down below. Looks like I'm running out of these. You can see how many I've used in the past. All the jumpers I had to fix, or all the pads I need to fix. Alright, so 1, 2, 3, and 4. So I just prepped them, or I staged them to be worked on. So let me rotate the board so that we're in a better position. So what I'm going to do is kind of line up the jumper to the pre-soldered, the tinned area. Also, I'm going to use my polarizer light to see. You can't really see too much of a difference there. I love this polarizer light. It's just expensive, so I don't know. But yeah, it's nice because a lot of times you can see stuff you can't normally see without it. So I have it kind of lined up, and it's essentially taking up the space where the pad would be. And then just run your iron, and now it's soldered on. Also, it's a good idea to tin, especially for this job, tin the pad so that when you go to solder on the flex, there's some solder on there for it to attach to. And I'm going to use a little clean cloth here to try to clean off my blade. There's a lot of flux on it. Okay, so there's going to be some excess jumper wire here, so you can just kind of mess with it until it comes off. So that one's done. And then we have, those are nuts. That's the ground. Oh, here it is. So same thing, except this one's at a weird angle, but it doesn't matter. I'm still gonna lay the solder lug straight, and you can see it lines up with the pad. So you don't need to follow the curve of that trace. I don't know why they made it like that, but you can just ignore that. And do the same thing, add some solder, and just kind of tin it so the solder flows underneath and over the solder lug. Tin the solder lug itself. Alright, so the solder lug is kind of dry as far as how much flux or how much solder is on there. So add some more solder to your iron. If it's too much, stab your iron into the brass wire you have for cleaning the iron. That looks like a solid solder joint. So, you know, when I do these repairs where like I have to do extra work, like if someone sent me this iPad as is, like without, not like this, but without being messed with, and it was fixable like normal stuff, then you know you get your normal price. But if you send me not just an iPad, but any device that, you know, someone tried to repair it and then just made it worse, and now I have to go through stuff like this, like trying to fix you know, somebody else's mistakes, then there's going to be an extra, essentially, cleanup fee. So make sure you know what you're doing, because all people I know that work on stuff after previous repair attempt will charge extra. So if you're not confident in these type of repairs, consider sending it to a professional first, or get ready to pay extra for the save, basically. Alright, it's kind of not soldered on. That's a little better. Tin the solder lug. And lastly is this one with the potentially, let me see if I can solder this on. Now I do have a lot of experience, so I could probably solder this on without bridging to ground. If you're still kind of new at this, you may want to UV mask that ground first before attempting this, so you don't short it out. Looks like I got it on. Yeah, there you go. So I could manage my movement, so I was able to solder on that pad without grounding it. Because you can still see, let me move some of this out of the way. So if I clean this up a little bit. All right, let's see if my polarizer light now is helpful, kind of. So, like here you can see my solder lug ends right before the ground plane, the exposed ground here. So this should be fine. Also, if you're not sure if this is soldered on right, you can try poking it gently to see if it moves, which this one doesn't. So yeah, those are soldered on pretty solid. So we're basically almost done. Now we got to UV mask the pads so that they stay in place when we are. All right, so now we got to add UV mask so they stay in place before we try to solder on the port. So what I'm using here is some UV mask, which I'll link down below in the description. You push out just a tiny little bubble. You get that on your blade. Your blade is kind of like your application, like your serving plates, and then you use your tweezer as your kind of brush in a way. So apply it. Oops, that's a little too much, so I'll just spread it around. So the goal here is to kind of coat this whole area so that when we put the UV light, it will solidify everything, and then we can expose back just the parts we need. So right now we're just kind of creating a coat of UV liquid. This will turn into a solid once we hit it with the UV light. And since this pad is kind of loose, I'm going to just do this pad as well, just for stability. So when we go to install the port, it doesn't break, and then we have to undo everything and risk messing up the other pads. Also, just be very conservative with your application of this, because it's easy to go too far and then you have a giant mess to clean up. So just apply it like that, coats the jumper, and then coat around it. So you can see that the liquid is kind of wrapping around the jumper. And this one's slightly a little crooked. Alright, let's leave it like that. So I hope you guys can see what I'm doing here as far as like the application of this UV liquid. So tiny little dabs of UV. And we're almost done with this step. By the way, if you guys are interested in learning how to solder, feel free to send me a message through my website. I do teach in a 90-day mentorship program, which teaches you how to solder, how to diagnose. It is a 90-day program. It's all virtual, so anyone in the world can join, as long as you're on Facebook and have internet and can join the live solder calls. You should be good. We have many students from Australia, Canada, Europe. I believe we have one guy from the Netherlands. So yeah, let me know. I'll connect you with Ben, who could tell you more about it, the pricing and all that. But it's like nothing there is out there as far as learning how to solder, because this stuff is not something you learn in 5 days, like in a week. You don't just fly into somewhere, spend 5 days. It's more like a boot camp where you could kind of get an idea of what you're going to be dealing with. But to actually diagnose and kind of get this stuff to click in your head, it does take a lot more time. So that's kind of the benefit to our program. And it's a mentorship. So we guide you through a lot of kind of the whole being in this industry of microsoldering, because I've been doing this for 5 years. The other people on the team have been doing it for a few more years as well. So combined, we have a lot of experience on how to deal with this kind of stuff. So this is tailored to repair shops and technicians who are doing this as a business. It's not really for hobbyists. But if you want to be a hobbyist and still, you know, sign up for the course. I guess, you know, we'll see. So anyways, now we're gonna apply the UV light. This is a little USB UV light which allows me to essentially hit it. Here, actually, I need to push this one down because this one's elevated. So push it down. Also try not to look at it with your eyeballs because it will hurt your eyes. Okay, see, now it's a little more solid. All right, so I'm gonna put it there for a little bit. So yeah, like I was saying, it is a 90-day program. We mentor you as far as how to do soldering, not only how to do it in your shop and how to actually solder and diagnose, but also how to implement it into your shop so it is profitable. There's a lot of repair shops out there who struggle with that profitability, and that's kind of what we mentor you with. So you get, there's a lot of perks to the program: lifetime access to the training portal, lifetime access to the recorded Zoom calls. But we do have live Zoom calls twice a week where I go through live repairs and kind of in a similar format where we walk through, you know, every step diagnosing, but it's a lot more thorough and it's interactive, so everyone is there live on the call and can ask questions. So let me know. By the way, so now the next step is to scratch out the pads. So you can see everything is, you know, solid. It's not going to go anywhere, but we now have to expose the solder joint so that, you know, the charging port can solder onto it. So I'm going to just scratch out what I need. You don't want the UV mask to be covering the solder joint, because then what's the charging port going to solder onto? But yeah, if you're interested in learning more about the program, go down below in the description and click the Contact Us link and send me a message. Say that you are a repair shop or you do, you know, repairs and you want to learn how to solder and diagnose and be profitable at this. You know, as a tech, it's super easy to want to just fix everything and kind of think of the business part as secondary, but that's kind of a big flaw in a lot of us, in that, you know, you do have to have that business mindset as well. And look at that, I've now broken another pad, but this appears to be just like this other one where these two are connected, and most likely the charging port within the charging port is connected as well. All right, so luckily no new pads were ripped except those, but those have connected to other, are sharing a line, so it's just redundant pads. I do get asked that a lot, like, why is there some pads that are NC or, you know, not needed? A lot of times it's just redundancy. You know, if we only needed 5 pads, then it'd look weird if it was 5, so they'll just put 6 or something like that. You know, it's just kind of symmetry and redundancy kind of stuff. So so yeah, this is what the final product looks like. Actually, let me scratch out a little bit here. Kind of hard to tell if it's, yeah, it should be fine. Okay, so now that we have the pads fixed, let's apply some flux here. And then I'm going to use my hook tool here to kind of just thin out this flux. You don't want super thick layer. So I'm going to excess flux, I'm going to apply it to the charging port flex so that I could reuse it. And then let me get a little, flatten it out a little more. Just be careful not to rip any more pads doing that. That way it's easy to solder on the port. All right, that should be good enough. All right, this is where really well, before I do that, let me show you guys. Make sure you peel off the sticker. All right, so this is where the polarizer light really does shine, so to speak, or no pun intended. Where are my tweezers? I need to have 2 sets of tweezers. But really, so charging ports, iPad charging ports have these little windows here on each side, and they have to line up with these little squares, alignment squares. So if you just try to do it like this, it might be hard to see. But you activate your polarizer, and now you can clearly see the little gold alignment square. So that's aligned, the bottom one's aligned. Okay, that's the alignment right there. Is it? Hold on. This is the tricky part, is trying to get this aligned without it moving after. All right, let me adjust it. Okay, so, and honestly, it doesn't have to be perfect. Although I do tend to focus too much on the little stuff. All right, so this is pretty much aligned. So this is without the polarizer, with the polarizer. And what I'm gonna do is I'm gonna hold the charging port like this. I'm gonna let go with my right hand, come in. I'm gonna have some solder wire here at the bottom, scoop some up, and then apply it to the port. Like that. Now it's kind of hard to see with the polarizer, so let's expose that again. And I'm going to do it one more time. So apply some solder and then essentially run over all the pads. The goal is to have the solder flow through the flex to the pads underneath. So in theory, this should be good. So let's apply some alcohol and kind of clean this up. And then after this, we're going to test with the Tshirt tester to see if this is fixed. So this is the Smart Mod Tshirt tester, the blue one. What I'm going to do is I'm going to connect the device to the charging port. Just the board and the port only, and push test. I said okay. So the first part is a charging port test. The second part is Tshirt good. Fail. Oh, look at that. Click more. Tshirt fail. Okay, so this iPad most likely came into the shop because of Tshirt failure, and the shop probably didn't diagnose this properly, replaced the port thinking the port is causing it not to charge, so let me replace it. But it seems like Tshirt is bad. Here's another way to see if Tshirt is bad. So now we have the USB meter here on the screen. You can see the green number right now is 000. We only care about the first 3 numbers after the dots or the decimal. So 0.000, 3 numbers. So I'm gonna start the chart and look at this. No, with nothing plugged in, just the board only. Plug this in to charge and you see it goes to 0.006. This is usually a sign that there's a Tshirt issue. A iPad board that is functional, not like this one, which is obviously has an issue, you will get some current draw. It won't be like a fully working iPad, but you will see some fluctuation. It should hit around 150 milliamp and then drop back down and kind of do the loop. But you can see here, it is fixed at 0.006. This is why when you have a USB meter, get one that has the 3 digits after the decimal point, because you can miss that 000. If it was 000 and no 6, so 000, it would have been a bad charging port install. But we're getting 006. That 6 tells us that the circuit in the TriStar is not functioning. Otherwise, you wouldn't get 006. So let's replace TriStar as well. So TriStar is located under this main shield, which this one has a sticker here, which is kind of annoying. Let me see if I can peel this off. All right, you know what? I'm just gonna leave it. I'm gonna pull up the whole shield with it. So I'm going to kind of grab one of these corners and essentially peel this thing off. Okay, so iPad Air 2 TriStar is located in here under this shield. And one thing about TriStar is there's a lot of ones that are cross compatible. So first, let's get underneath there. I'm going to use some wire cutters here to just kind of peel up this section and give us access to TriStar. I could technically use the little mini Dremel, but this is faster. Okay, throw away that little piece of metal. All right, so now we can see TriStar. You can see it's 16. The very top row is the part number for this chip, 1610A1. So if you have any TriStars that are 1610A1, A2, A3, these are all backwards compatible with the 610A3B, which is what we're gonna use to replace this one. So actually, I will get it out after I remove this one so I don't lose it. So remember, 610A3B. This is the TriStar that comes in iPhone 7, iPhone 7 Plus, I believe iPad Pro 2nd gen, iPad Pro 12.9 2nd gen, iPad Pro 10.5. So what you do is, let's remove this one. Well, before that, the orientation dot was up here, and being that ZXW oftentimes won't have too much info on iPads, let's go ahead and mark that orientation. So I'm just gonna make an X here. I'm gonna scratch it out so that I don't lose track, because if you lose track, you might put TriStar the wrong way. You could kill the iPad. So what I'm gonna do is I'm gonna put my hot air to let's do 420. Let me adjust this light. All right, so I'm gonna do 420 and 100 air. iPads do take a lot more heat to the thermal mass. So this heat is dissipating really fast on this iPad. Let me add a little more flux because I didn't finish doing that. Alright, so I got some flux in there. So 420 and 101 air. So the way thermal mass works is the heat just spreads. You know, there's a giant board here, so the heat is going to spread across the board. And it takes forever to remove chips compared to an iPhone, which has a lower thermal mass. Yeah, this is still solid, so I'm not going to try pulling it yet. You could also try to bump the chip to see if it moves. There you go, it moved. Now I just pull it up. One of the nice things about TriStar is super easy to just place back down on top of it. So let me apply some flux. Right now, let me get my TriStars. Drop it here. All right, so this is what I was saying, is we're gonna install a this revision, which is 610A3B. And this one is backwards compatible with the ones ending in A1, A2, and A3. Now the ones it's not compatible with is first gen Lightning devices like iPad mini 1, iPad 4, and iPhone 5. Also not compatible with USB-C iPads that use A3C, which is a different TriStar. But outside of that, it'll be compatible. Alright, so let me place it. The orientation dot matches the little X I scratched. And I'm gonna let go. And this should install any second now. Just keep hitting it with air until you see it kind of lay flat. And you can see it moving into position, because now the solder balls from the board have combined with the solder balls on the chip. And you see if I bump the chip, it snaps back into place. That means all the solder is liquid and is in that liquid state that allows it to snap into place because of the surface tension. Surface tension has that behavior when it's, that's why surface tension is what makes this drop of alcohol stick to the needle here at the end. It's the same thing, is that the liquid solder is kind of just sticking to the board and to the chip, and that's what kind of pulls it together. So yeah, these are all concepts we teach in the course. And you can see here from the side view, the solder balls are nice and solid, I guess, or even. There's no bridging. So yeah, this is installed. So now let's test this again with the TriStar tester and see if that solved the issue. Alright, so while we have the USB meter here, let's just go ahead and test the charging. So remember, it was sticking at 0.006. Now we have 0. Oh, look at that, it just way more than 0.006. So you can see how now it's doing something way different. So this usually tells you that the charging circuit is working. At least something is happening, so this is a good sign. Then lastly, I am going to now I'm going to plug in the TriStar tester and then run the same test again. A lot of this troubleshooting and diagnosing is just trying things, testing before and after, and see what kind of changes you see. Alright, so charging port pass. So, high chance this is fixed. So now let me reassemble and test one more time. Okay, so here's the final test. One of them, I guess, is we're gonna plug it into charge, and look at that. We have a 2.1 USB amp draw. We also have a low battery symbol here. So far this is a good sign. We have a solid charging current. It's not jumping around. It's not, it seems like it's working. So one thing to consider is if you do all this and your iPad is still not charging, so you see fluctuating currents where it's not like a 2 amp or 1 amp, solid line. It is like jumping around. Check the battery connector. Make sure the battery connector is not damaged as well. Make sure the battery screw is the right one. If you put one that's too long, then the board and the battery will not make solid contact and it won't charge properly. Also, just a bad battery, or sometimes when these iPad charging ports go bad and TriStar goes bad, these iPads will sit on a shelf for a long time and the battery itself goes flat and is just dead. So sometimes the battery itself could be bad, so you have to measure the voltage of the battery. Make sure it's above like 3.1 volts at least. If it's not, you will have to inject voltage directly into the positive and negative terminals. I usually use 4.3 volts and like 2 amps and just charge it up manually for a good 30 seconds. That should be enough to boost it up above the voltage it needs to be for the iPad to detect it. and then the iPad can charge it like this. So this one was at 3.4 volts. I actually checked this right before I did this test, but you can see I push the power button, I get the little battery symbol. So all signs point towards this being fixed. So what did we learn today is, one is check the pads. You don't have to jump every single one. Just because the pad is missing doesn't mean it's required. Like I said, it could be redundant or it could just be there for symmetry. So keep that in mind. Do what I did. Check ZXW. See if there's duplicate pads on ZXW. Use your multimeter. Check for continuity from one pad to the other within the board, within the flex. If there is, then it's just a duplicate pad that's not needed. Another thing is careful with your UV mask. Don't put too much. Put a thin layer. Scratch out, once you cure it with the UV light, scratch out just the pad what you need. If you want to get fancy, get a polarizer light so you can clearly see the alignment holes or alignment squares, so that when you go to place the port, it's super easy to align. Because without it, you have flux, the pads are gold and shiny, so it's really hard to kind of see those alignment squares. But yeah, I think that's the main thing. Also, when you're diagnosing this, make sure you fully know what you're gonna fix. At least for iPad charging ports and TriStars, it's so easy to know which one's which using a TriStar tester. Check the USB charging current. So like if the port wiggles and you see the charging current stop, that means the charging port has disconnected. But see, I could wiggle it and it's still at basically 2 amps. So if you wiggle it and it charges, you wiggle it another way and it stops charging, clearly that's a port. But if you plug it in, you get 006 USB charging, then that's clearly something else. It could be a short on the board, it could be TriStar, it could be something else. So always keep that in mind. Just because you get 006 does not mean it's a charging port, and just because you get 000 doesn't mean it's TriStar. You do have to kind of understand how this works. Highly recommend TriStar tester, either like this one or the ICC Pro. This one works as well. And really what they do is they first test the charging port. Because if the charging port is bad, then it's not going to be able to test TriStar itself, because it can't reach the signals it has to send out. It won't reach the TriStar. So make sure you know what you're doing before you start replacing parts, because this guy could have avoided damaging the port, unless the port was physically already damaged and it needed to be replaced. But yeah, this whole fiasco could have been avoided by the person who sent me this if they had just diagnosed it properly and just replaced TriStar. Although they could have messed up TriStar as well, so who knows the full backstory. Obviously, they're not gonna. Most likely, they're not gonna admit to, to what happened. Or it could be the customer. This came from a repair shop. It could be their customer. The end user, the owner of this iPad, is the one who tried to replace their own port, destroyed it, and then that shop just sent it to me just because they didn't want to risk trying to fix it themselves and making it worse. So I don't know. I'll see if I could find out and let you guys know in the comments. Okay, so now that it's been charging for quite some time, it has now turned on. You can see 3% charge, and it is fully working. So one thing also is make sure it keeps charging when you unlock the screen and lock it, because that is somewhat a common issue, either caused by the battery pins, the battery itself, or the battery screw is not tight enough to hold the battery and the board together. But if it's not that, it could be PMIC. So something to just be aware of. But for now, you can see this iPad is charging. So thanks to everyone who stuck around for the whole video. We got the iPad fixed, fully working. You guys saw that running jumpers isn't that hard if you kind of know what to do, what to look for. And I do appreciate all you guys who are liking and subscribing the videos. If you haven't already, smash the like button. subscribe, share this video with all your friends, share this in the Facebook groups. Check the links below in the description for the tools I use, the jumpers, the UV mask, UV lights, TriStars, all that good stuff. And don't forget, get a t-shirt. If you buy a t-shirt, it really supports me and the channel, and we'll keep making more videos here for you guys to learn how to microsolder. So thanks a lot for watching, and I'll see you in the next one.